So today we're going to look at the second part of 2.1. Okay, so we're still talking about angles. And we are going to use the two formulas for the conversions we learned yesterday. Not so much converting something to degrees, but more converting something to radians. Okay, the formulas we learned today have to work in radians. So let me. So there we go. Part two, not part one. So I'm going to start out just by looking at this diagram. Right, and just to kind of simplify it a little bit, that's all you really need to draw for now. Okay, you've got a circle. And inside that circle, I have two angles. Now, when we don't know an angle, or when you don't know something in math, a lot of times we use a variable to represent it. Like in algebra, you use x a lot. Well, in trig, we use a Greek letter when we don't know an angle. It can be many different Greek letters, but the one that I'm going to use here is theta. That's T-H-E-T-A. Theta. Right, so it just represents the size of this angle, which I don't know. And I have another angle down here. I can't use the same variable twice, so I'm going to just use something different. I'll call it theta 1. I could call the top one theta 2 if I wanted. I could really use any variable that I want. Now, each one of those angles has two rays coming from the center. And at some point, those rays hit the edge of the circle. Between the two dots where the rays hit the circle, I drew that curve in red. Anybody remember what that's called? It's it's an arc. And in this section, just to use the same letter that your book uses, they let an arc be represented by the letter S. Okay. This arc down here in red is different, so I can't use the same letter. So I'm going to call it S1. Right. So arc S is formed by theta, S1 by theta 1. It's just a circle with two angles in it. Question on that? Okay. So I'm going to set up a formula to figure out how big an arc is on a circle. But there's a connection between the size you make this angle and the size you make this arc. Let me see if I have. Let me make a circle. And let me make an angle like this. Okay, so there's an angle. And the arc that it makes is that. Okay, now let me draw another circle. Do it that way too. All right, so there's another circle. And let me draw another angle. I'll put my initial side here and my terminal side over here. All right, so let's look at the first picture, the one on the left. How big is that angle on the left? Yes?
90 degrees.
It's 90 degrees. And how much of the arc does the circle take up? How much of the circle does that arc take up? A quarter. Right? A 90-degree angle took up a quarter of the circle. Now look at picture 2. How big is the angle in picture 2? Don?
180.
It's 180. Okay. How much of the circle does the arc take up this time? Ben? Half of it. So what's the relationship between a 90-degree angle and a 180-degree angle? 180 is how many times bigger? Twice. The angle in picture 2 is twice as big as the angle in picture 1. Well, the arc in picture 2 is also twice as big as the arc in picture 1. And that relationship always happens. If you make the angle 3 times as big as it was, you'll make the arc 3 times as big. If I made this angle half as big, then I would end up making the arc half as big. Okay, that's called directly proportional. As you change one thing, the other thing changes in exactly the same way. Right? So there's the angle size and arc size are directly proportional. What that means is you can set up something like this to solve it. Does anybody remember what this is called when you have a fraction on each side of an equal sign? You know, sometimes it might look like this. I'm just making up numbers. Yep.
Conversion?
It does end in shun, but it doesn't begin with C. But it does end in shun. Yep. It is an equation, true, but because it's a fraction on each side, it makes it a certain kind of equation. It's a proportion. That's a proportion. When you have relationships that are directly proportional, you are allowed to set up what is called a proportion if you want to make an equation to represent it. So what we have to do is set up a proportion. Now, it's going to be kind of like what we did yesterday, where you have to know something to start with. Let's say I wanted to set up a proportion that gave somebody a way to convert, and I always go back to something simple, like feet to inches. We could say 12 inches, there's 1 foot, and now let's say you gave me 86 inches. Is how many feet? That's a proportion. The whole key in that proportion is this. You had to have a fact that you knew was true on one side, and then you could put information that you're trying to find on the other side. If you don't have this fact to start with, you're stuck. Can't do it. So this is what we have to figure out. We've got to figure out something to start with. Now, if I start with 12 over 1, does that limit what number I could put up here? Because I chose to pick a 12 and a 1. Like, could I only put an 86 here? It only works for 86? No. I could put 73, I could put 112. It doesn't matter. Just because you started with a 12 and a 1, it doesn't limit what you can do. You're just starting with something that's true. If you want to start with a 24 and a 2, that would work as well. But this is simpler. All right. So, this is where we have to figure out something we already know is true. And we mentioned something from yesterday. Before I even started to explain how to convert between degrees and radians, I gave you guys a picture of what a radian would look like. And does anyone remember from that picture we had yesterday? I said that if the size of this arc was exactly the same as the size of the radius, then this angle had to be a certain size. Does anybody remember what the size was? If the length of the arc in red is exactly equal to the radius, then this angle would have to be how big? Yep.
1 radian.
Exactly, 1 radian. That's like saying if you have 12 inches, it has to be 1 foot. That's just a fact that's true. If this angle is 1, all right, RAD, just so we're clear on that. If that angle is 1 radian, then S1 has to be equal to the radius. It has to be. It's like saying 12 inches has to be 1 foot. Just it has to be. That's the definition. All right? So here's a fact that we can use to start this off. All right? If that angle is 1 radian, I guarantee you that that arc length will be equal to the radius. It has to be. So now we just need to set up a proportion. The important thing when you set up a proportion is you do it the same way on each side. So these are the 4 things that are going to go in the 4 spots of my proportion. have an angle and an arc length, another angle, and another arc length. So let's just try to set it up the same way on each side. I'll do the left, and then we'll see if somebody else can follow the pattern I did and do the one on the right. So I'm going to compare arc length S to angle theta. So S is to theta as this is to that. And I need to fill those in. What do you think would go in the top on the right-hand side if I'm setting this proportion up using the pattern on the left? Pete?
S1?
Yes. S1 would have to go in the top. All right. So Pete told us S1 goes in the top, and that means theta 1 goes in the bottom. So here's the pattern. Arc over angle, arc over angle. You have to set it up the same way on each side. If I decided to put angle on the top and arc on the bottom, that would have been fine. You just would have to do it the same way on the other side. Okay, so here is your proportion that represents that diagram. Now, we're going to fill in what's in that red bracket. We're going to change, I'll just squeeze it in under there. The S isn't going to change, and the theta isn't going to change. But it says, suppose theta 1 equals 1 radian. So we're going to plug in a 1 there. And then it means the length of the arc would automatically be the same as the radius. This part right here, that's like your 1 foot, 12 inches. That's a fact that is always true. Not as natural to some people as 1 foot equals 12 inches because it's something new. You haven't worked with this as much, but it's exactly the same idea. Now, usually when we have a proportion, we do something to solve it. Does anybody remember the name of the technique you use to solve a proportion? Yes, two words in it. Yep. Exactly, very good. You're going to cross multiply. This times this equals that times that. And that will be the formula that we want. So, S times 1 gives me S. R times theta gives me R theta. S equals R theta. That's the formula for finding the length of an arc. So that has 3 variables in it. We'll just label which one is which. That's the arc. R is the radius. And theta is your angle. But if we go back up, what units did we assume? And I didn't say this, I asked somebody and they told me. What units was I assuming my angle was in from the very beginning? Yes? Not sure? Anyone? Done?
Radians.
Radians. Suppose that theta 1 equals 1 radian. We assumed radians because that's the fact I gave you yesterday, right? So we use that fact. So that means if you're going to use this formula, your angle has to be in radians. If it was in degrees, that'd be the first thing we have to fix. Now, there's 3 variables. You'll always be given 2 of them. Okay, as long as you know 2 out of 3, you can solve for whatever the third one is. Let's try an example. So there's 2 ways that I can kind of give you a problem like this, and I'll put this back up in a second. But I can write out the whole problem just like that, or I could just draw a picture of the problem like that. Okay? Same thing. Okay, this one I decided to just write it out. So when it's written out, you want to kind of read through it and see, well, what's really important here? What's the important things that I need to use? So the directions say find the length of the arc. James, what's something that's important in that sentence?
The arc part.
Okay, what about it?
We have to find the length of it.
Okay, so that's what the question's asking you to find. So what I just circled, that's the variable. You don't know what that is. Okay, Frankie, what's something else that's important there?
Probably the angle part.
And what's the angle part?
Where it says like the central angle.
Central angle of how much is it in this case?
Pi over 3.
Yep, it's pi over 3. Okay, Dom, where's that going to go? That pi over 3 in this formula?
It's going to be the theta.
It's your theta. All right, and Raymond, anything else here that's important?
4 inches.
The 4 inches, absolutely. Where's what is that? The 4 inches.
Radius.
That's my radius. Radius of 4 inches. So that is going to go right there. Now I said right in the beginning that your angle had to be in radians. It already is, so we don't have to worry about that. So let's fill in what we got. S equals R times, and theta is pi over 3. If you want to make the 4 a fraction, you can. I usually don't, but you could. And then you just multiply straight across. We don't need a calculator because it didn't say to round anything to 2 decimal places. 4 times pi is 4 pi. The bottom, 1 times 3 gives me 3. And Colby, what did I just find again? 4 pi over 3 was the what?
The length of the arc.
The length of the arc.
In inches.
So, yes, exactly what he said. He said inches. Okay, we have to put a label on that. S is length. Length in this problem was inches. It could have been feet, could have been anything, but it was inches. All right. And if they did want a decimal, okay, all you'd have to do on your calculator is type in 4 pi divided by 3, and you get 4.19 inches. Okay, they're not asking for a decimal here, though. So when you see directions that say leave your answer as a multiple of pi, that's what I have circled. If you see directions that say round your answer to 2 decimal places, that's what's on the calculator, 4.19 inches. Any questions on that one? All right, let's try this one. So we're going to learn 2 formulas today. So the first thing I like to do, and you've only learned 1 formula right now, is just read the problem and see what formula you're going to need to use. This is about arc length. So right away, just write the formula down. And Cassidy, what's the formula that we just came up with for arc length?
Is that the S over?
Yeah, it starts out S equals
R and then the symbol.
Yep, and that symbol, does anyone remember how do you say that symbol? Yeah?
Theta.
Theta, yes. So again, the problem is saying find the length of the arc, so we know S is the arc length, that's what we don't know. So everything else needs to be given to me. Any thoughts about this problem before we start plugging in numbers? Yeah, Jaden? We have degrees. Why? What's wrong with that?
We're gonna need to change it to
We have to change that to radians. If you leave it as degrees, it's wrong. Okay. So off to the side, let's change that to radians first, and then we'll use our formula. So 130 It's pi over 180. And all you can do here is really divide the top and bottom by 10. So 130 degrees is 13 pi over 18. Okay, we're not going to round that off. We're just going to leave it just like that. Okay. And now they tell me my radius is 8 feet. So we got 8 times, if you want to make it a fraction, you could. My angle is 13 pi over 18. Okay, Autumn, anything I can reduce here just to make these numbers a little smaller? So if you look, is there any number that would divide into something in the top and something in the bottom?
2 can go into the 8 and 18.
Yes. Whenever you have multiplication, you can always reduce a number on the top with another one on the bottom. If it's addition, you can't do that. Or subtraction. So multiplication, you can. 2 goes into 8 4 times. And 2 goes into 18 9 times. So Mateo, if I do that out, what's 4 times 13 give me?
52.
Good. 52 pi over 1 times 9. So 52 pi over 9. And Katrina, this time, what am I looking for a label on that? Feet. Right? We were finding a length. There's 2 lengths in this formula. S is a length, R is a length. Theta is not a length, that's an angle. So we found a length. Lengths were measured in feet, so we need a label of feet. Okay, any question how you type that in if they wanted a decimal on the calculator? All right, let's take a look at this one. So this one says we have an arc length of pi over 4 centimeters and a radius of 12 centimeters. Find the angle. Jody, what's different about this one? This one's a little different than the first 2. Yeah, we're going to solve for the angle, for theta. We're not solving for the arc length this time. You're giving that to me. So Ava, where is this pi over 4 going to go?
It's going to go in the theta.
So is that an angle, pi over 4 centimeters?
It says arc length.
Arc length. Yes, it's arc length. So which letter is arc length?
I forget.
S.
S. So arc length is S. And what about the 12 centimeters? Don, where's the 12 centimeters going to go?
In the denominator of the second half.
So is it the S, the R, or the theta?
The R.
It's the R, yeah. So we're just going to fill that in for R, and theta is what we don't know. So we've got pi over 4 equals 12 theta. And Pete, how do I undo multiplication here and move that 12 over to the other side?
Divide.
Divide, yeah, good. We're going to divide. divide by 12. And that's the same as putting a times 12 in the bottom of the other side. So I divided the right side by 12, and I divided the left side by 12. That's good. All right, so my angle is pi over 48. Now, do I need to write a label on that? Yep, Jess?
Will that just be,
So think about what we solved for, and think about if we put a label on that kind of thing. Yeah?
will that just be a degree?
I agree that we did solve for an angle, and what unit does this formula always give us for an angle? Yep,
Radians.
it gives us radians. So do I need to put RAD?
No.
No. That's it. That's your final answer. Any question on that? So that's an example where you solve for the angle. The first two were an example where you solve for the arc length. The last one is an example where you solve for the radius. And this time it's a picture. So it says find the radius. They've given you the formula. Aiden, any thoughts before we start using the formula?
We're gonna have to change 36 into degrees, it's gonna need to be radians.
Yeah, we should change that to radians right away, and that's going to end up as pi over 5. Okay. So 36 times pi divided by 180. And if you divide 36, it does go into 180 nicely. Okay, so we've got our angle as pi over 5. How about Ben? Where's the 13 gonna go? Is it the S, R, or the theta? Yeah, it's S. It's the length of this arc on the outside. So that's my S. Frankie, what's my radius in this one?
35. Wait, what's that number?
This one is a 36.
Oh, 36.
Is that, so that's 36, what's that symbol on it?
Wait,
Degrees.
degrees.
So would that be my radius, 36 degrees?
Yeah. No.
So radius has always be measured in something like inches, feet, centimeters. So if it has that little circle on it, that means it's an angle.
Oh, okay.
So any other thoughts what my radius is here? What's the question asking you to find?
Find the radius.
We don't know the radius. Right? So this time we're going to just leave the radius as r. We don't know. And lastly, theta, that's my angle, which we converted to pi over 5. All right, so now we've got a variable multiplied by a fraction. It would be just like having an equation like this. There's a way to get rid of the number in the top and the number in the bottom at the same time. Does anybody remember what the trick is to get rid of both of these numbers at the same time? Yep, Tom?
Multiply by 5 over 5.
Yeah, what's that called?
Inverse.
Not inverse. Yep. Reciprocal. Good. I'm going to multiply both sides by the reciprocal. 5 over pi. 5 over pi. Gone, gone. That gets rid of everything in one step on the right. And that's going to give me 50 plus 15, which is 65. Okay. Raymond, do I need a label on that?
No.
Okay, what did we solve for?
The radius.
Radius. And radius is what kind of thing? Is radius an angle or is it a length?
Length.
The length. All right. So anytime you solve for a length, you do have to put a label on it. The label you need, you've got to scroll back up and read what they had. Feet. Okay, so they measured lengths in feet. And that's your final answer. Any question how to type that in on a calculator if they want a decimal? Yep. So to type it in, you just type in 65 divided by, and use the pi button. So it would come out to about 20.7 feet. Can't really get it on the screen. The other one. All right, so that's our. So the last formula we're going to look at is about the same difficulty as that one. And it starts off with a very similar picture. And what I'm going to do right now is going to feel very similar to what we just did. Okay, I'm going to kind of go through the same steps to figure out this formula. So first of all, it's about a shape. Maybe you know this name, maybe you don't. It's called a sector. Okay, you can think of a sector as it's like a piece of pizza. It's got two sides on it that are cut straight, and the top side is a curve that's part of the circle. And now this formula is not really getting at what the length of the arc is, it's getting at the size of the area shaded in that region. That's what we're trying to find. So I've drawn a very similar picture that I had last time. In fact, it's almost the same picture. I've got two angles. I called one angle theta. I called the other angle theta 1. And then the area that's enclosed by the angle theta, I called that A. And the area that's enclosed by theta 1, this little spot here, I'm calling that area A1. Now, we're going to hope that we can set up a proportion again, but we can only do a proportion if this picture is what we call directly proportional. So let's draw two pictures and kind of compare them and see what happens. Let's make a circle. Let's make another circle. Let's draw an angle. And let's shade in the area that represents. How big is the angle in picture 1? Yep, John. 90 degrees. And how much of the circle is shaded? A quarter. Okay, keep that in mind. All right, so now I'm going to do the same thing. Just looking at a different example. How big is the angle in picture 2? Don?
180.
180. And how much of the circle is shaded in? Yeah.
Half.
Half. So I had a 90 degree angle. I have a 180 degree angle. Notice what happened. If I took the size of the angle and doubled it, it doubled the size of the area that it represented. If you took the size of the angle and tripled it, it would triple the area. If you make the angle half as big, it would make the area half as big. So in other words, those are directly proportional. As the size of the angle changes, the size of the area changes directly with it in exactly the same way. All right. Any question on that? All right. So let's see if we can set up a proportion. And then we'll go from there. Yep, just hold it right up to it. I've got 4 spots in my proportion. I've got 4 variables that I just circled. This time I'm going to see if somebody can tell me how to set up one side. Anybody tell me what I could put on the left-hand side? And there's lots of ways to do it, as long as we're consistent. Yep, Jaden? All right, that's going to work. A over theta. Now that she chose to do that, there's only one way to set up the right-hand side. A over theta equals
A1 over theta 1.
A1 over theta 1. Now, right now, that's useless. There's no numbers in it anywhere, right? We have to get a true fact on one side, just like this. We have to put something there we know is true. And then we can leave the other side as question marks, and that's what we can fill in and cross multiply. So, let's go back to these 2 pictures. Then I'm even going to extend it a little bit. How much of the circle was shaded in here? Quarter. So let's make a little chart. Angle. Area. So if the angle was 90 degrees, the area was a quarter of the circle. The angle was 180, the area was half. How about, let's go with an easy shape to find the area of. We don't really have a simple formula off the top of our head for finding the area of quarter circles or half circles. But what about this? What if the angle was 360 degrees? How much would the area be? Pete?
That's all of it.
All of it, yeah, the whole thing. So here is a connection we can figure out. If the angle is 360 degrees, then the area is the whole thing. We just have to find, well, how much is the whole thing? Okay. So let's start with the 360. Does anybody remember what's 360 degrees in radians? Vivian?
Is it 2 radians? Or no, is it 1?
It's two something. Jake? 2 pi. Yeah. We're going to do this in radians again. So if the angle is 360, which is 2 pi, the area is the whole thing. Well, now I need to know what that formula is. What's the formula for the area of the whole thing? What's the formula for the area of a circle? Remember maybe something that's in it, Jess?
Radius and then diameter.
So it does have a radius in it. That's the heart of it. Anyone else remember something in it?
Pi times radius squared.
Yes. Pi times radius squared. So here, this and that, there's my connection. If the angle is 2 pi, then it automatically forces the area to be the whole thing. We call the whole thing pi r squared. That's my 1 foot equals 12 inches. That's a fact that's true. So let's go back here. Suppose that you had an angle that was so big it took up the whole circle, then that would automatically mean the area is is pi r squared. Why? Same reason why 1 foot equals 12 inches. That's just, it's a fact that's true. The angle is 2 pi, the area would have to be pi r squared. Now, fill that information in your formula. We'll cross multiply, and then we'll have our formula. All right, so A, we don't know. That'd be something they tell us in the problem. Theta, we don't know. That'd be something they also tell us in the problem. Now let's fill in our 1 foot 12 inches. Let's fill in the fact we know is always true. A1 is pi r squared, and theta 1, oops, forgot the 1 on my theta before here. Theta 1 is 2 pi. Now you can cross multiply right away, but there's actually something you could do first, just to make that a little easier to work with. Anyone see something we could do first in that fraction? No?
Cancel out pi.
Yeah, we could cancel out the pi's. I mean, it's not a lot, but it's a little bit. Gets rid of something. And now let's cross multiply. Jacob, what do I get when I multiply those two together?
2a.
Yeah, I can't really do much with it. It's just 2a. Equals. Now we'll cross multiply that. Theta r squared. That's just r squared times theta. You can't do anything with it. Now that's almost our formula for area, but what don't we want next to the a? If we're trying to get a formula for area. Right now we have a formula for double area. Yeah? We don't want the 2. So you can get rid of the 2 by dividing each side by 2, or multiply each side by a half. But that's the same thing. So I'm just going to do times a half times a half. 1/2 times 2 gives me 1, so that's gone. And I get my formula. That's the formula for the area of a sector. So that's the other formula that we're going to learn today. I'll just try to squeeze it in here. So this is an area of a sector. So the A is the actual area. The R, how about Lacey, what do you think the R stands for? What did the R stand for in our last formula?
Radius.
Radius, yep. So R is my radius. And Colby, how about theta? What's that?
The angle.
That's my angle. Anything special we got to be careful with?
That's the angle and radius.
Exactly. Way back when we did this suppose step, where did I write it? I supposed we had 2 pi radians. We could have done 360 degrees, but the formula is a little nicer looking if we do radians. All right, so same deal. You've got 3 variables. You'll always be given 2 out of the 3, and your job will be to solve for the 3rd one. All right, so we'll try a couple examples of this one, and then that's it. Okay. So first thing when you look at it, read the directions and say, okay, do I need the arc length formula or do I need the area formula? This problem says find the area. First thing I'll do is write it down. Okay, Autumn, what's the formula we just came up with for area?
A equals 1/2 r squared.
And what comes after it?
Don't remember the name of it.
All right, what's the name of that thing again that comes after it? Yes, Angelina? Theta. All right, find the area. We don't know A. So that's going to be our variable. Jaden, what's my radius in this case? 4 centimeters, yep. And Jess, what is my angle? Pi over 6. Don't have to worry about converting it. I know it's not degrees because it doesn't have the degree symbol. So it's already in radians. I'm good to go. All right, Mateo, what is 4 squared?
16.
And then half of that?
8.
8 times pi over 6. If you want to make that 8 a fraction like we've done before, you can. I would reduce here. How about, Katrina, what can you reduce the top and bottom by? 2?
And yeah, so divide.
Yep. So 2 goes into 8 how many times?
4
And how many here? 3. So now we get 4 pi over 3. All right, now Johnny, what did I just find there? I found the area. So anybody think they could tell me what my unit would be? Because we found an area. Yeah, Colton?
Centimeters squared.
Centimeters squared. Good. Area is a two-dimensional concept. It's not length. So area should have an exponent of 2. Just like that. Okay. Any questions on that? All right, let's try this one. Okay, find the radius. All right, so a couple things here. First, you got to deal with that 45 degrees. Can anyone tell me what that would be if you change it to radians? After a while, if you've worked with like the 30s, the 60s, and the 45s, those multiples come up a lot. So some of these you may have memorized. This is one I haven't memorized yet.
Is it pi over 4?
It's pi over 4. Yep. All right, now we're ready to fill in. A equals 1/2 r squared theta. I'm going to move this over here. Okay, so I want to get that r squared by itself. And technically, you could do 3 things in the same step. You could move the 1/2, the pi over 4, and get rid of that exponent of 2. If you're good with algebra, if that confuses you, you should probably stick with 1 step at a time. So let's start with the pi over 4. We had something kind of like this earlier. Anybody remember how I can get rid of the pi and the 4 at the same time? Yeah?
multiply this reciprocal.
Multiply each side by the reciprocal. 4 over pi. 4 over pi. That's going to cancel all kinds of stuff. 4's are gone. The pi's are gone. And the pi's are gone. So now on the left, you have 32 over 3 equals 1/2 r squared. All right, how about my next step? How can I get rid of that 1/2? Okay. You could, yeah. What could you divide each side by? If we take a half and divide it by 2, we're going to get a quarter.
Oh, alright then, just a half.
So you could divide both sides by a half. But what's an even easier way of thinking about that? Dividing by 1/2 is the same as multiplying by 2. So let's just do times 2 times 2. If you want to put it over 1, go for it. 2 times 1/2 is a 1. That cancels out. 2 times 32 is 64 over 3. And now I have r squared. Okay. And lastly, how do you get rid of an exponent of 2? Okay, adding, subtracting, multiplying, not going to help anymore. We have to do something different. Yep. Square root, exactly. And when you have a fraction, the way you square root it, you do the top and you do the bottom separate. Okay, when we square and square root, they cancel. So now we have r. The bottom, unfortunately, I can't do anything with that. So I have square root of 3. But the top does come out nice. The square root of 64 is 8. Now, as far as the trig, we're done with like the trig part of this problem. What's the only problem with that answer from kind of like an arithmetic point of view? It's not really something I've taught you. But yeah? Yeah, anytime you do something in math, if it ends up with a square root in the bottom, you're not supposed to leave it there. So the way you fix it is you multiply the top and the bottom by the square root. It's not going to get rid of it completely. All it's going to do is move it from the bottom to the top, which is where we want to leave it. So in the top, you have 8 times the square root of 3. And in the bottom, the square root of 3 times the square root of 3, that's the square root of 9. Which is how much? 3. Yeah. And that is your radius. So if you're wondering, well, if I leave it like this, am I going to lose points? Well, it depends the kind of question. If it was a multiple choice question and you get this, I'm not going to have that written as a multiple choice answer because it's not proper. I would have this written. Okay. So you have to know that these two things are the same. I forget what our units were. Inches. Yeah.
Multiply them? Why do we have to actually multiply them instead of just taking off the square root? Like
Right here?
Yeah, we know if we take off the square root, it's going to be 3. Why do we have to multiply it to get the square root of 9?
So I was just showing people why it's 3.
Oh, okay.
Honestly, I just do that in my head and I write 3. Yeah. But if you're like, well, how did he get 3? It's because I have the square root of 9, which is 3. That's how you get it. So that's the area formula. Those are the 2 formulas for today. All right. So in the homework, okay, there's going to be 2 word problems. I think one of them is about a clock. And if you had a hand on a clock, you wanted to figure out, like, say, how far the tip of the minute hand moved. Give you a hint. It moves like this. It moves in the shape of an arc. So it has to do with an arc length problem. Now, the length of the minute hand, we didn't call it that in class because we weren't dealing with a clock. But the length of the minute hand is really like the what in our formula? It's like the radius. The length of the minute hand is a radius. So they're going to give you a problem where they tell you the length of the minute hand, and you're going to have to figure out how far the tip of it moved between, say, 12 and 3. Well, that's an easy one because you know the angle is 90. The nice thing about a clock is everything is uniform. So every hour is 30 degrees. 30, 60, 90, and so on. So you can easily figure out the angle on a clock because the numbers are nicely spaced. And then I think there's one other problem about a pendulum. And it asks you if you had like a 2-foot pendulum and it swings back and forth 20 degrees, how far is the pendulum moving? Well, the pendulum moves in an arc. And the length of the pendulum, that's like your radius. Right, so there's two word problems that touch on that stuff. Okay, but we'll take a look at them tomorrow. Yeah.
So in a problem like that second one, pendulum, we would be measuring the whole arc, not just the center to one side.
Yeah, I think when they draw the picture, they draw it like this. And they say that it swings back and forth 30 degrees. Yeah, so I think they make it clear like that. And they'll tell you this is like 8 inches or something. Find the length of the arc. All right, so that's the homework on page 99. So 71 to 87 odd, and 91 to 94 all.